Well, hello everyone, and welcome to another episode with your girl Audrey Codner from ACG Math Tutoring. A for algebra, C for college algebra, and G for geometry. So, if you are a person that is looking to get some assistance with the GED, with the ASVAB, with the ACCUPLACER, maybe even a little bit of SAT work, ACT work. Maybe you're trying to get an apprenticeship as an electrician. Anything that has to deal with basic algebra, I am your girl, and this is the live for you. So, as it says in the title, we're getting back to the basics. You know, the school year is about to start up. Sometimes we just need a quick little refresher, or maybe we just want to just do some math, a little nice, cool, relaxing type thing. This is definitely the live for you. So if you know of anyone that's going to go for the GED or about to get started for school and they need to brush up on some basic math, please go ahead, share this live out. I want you to be active. I want you to ask questions. This is going to be a safe space. If you are a type of person that, hey, math is your forever thing and you know how to get to A and B so much quicker, this is not the live for you. Okay, I appreciate you coming on in, but I don't want you to be bored. So if anything, come on in, have paper ready, and if not, I also have a place where you can go to get a lot of the replays so you can get all that stuff done. So let's go in. As you guys are coming in, go ahead and tap the screen. I usually get started after 1K, and then we're going to be breaking down concepts. So as you guys are in here, hey Jess, how are you? Hey Neo, thank you for coming. Excel, thank you. Gino, yes. Oh, it is Happy Lefty Day. My parents would definitely be proud. For all you lefties out there, I know it's like 9:33 at night. I also have my notebooks ready to go. I'm getting started on my newer edition of my math notebook. So this is going to be the first part for book 6. And for those that are all knowing, and you see a lot of my notes that I have here, I have what's called Audrey's notes. So if you want a copy of my notes, you can actually go on and look at the big A and get a copy of Audrey's notes, which basically has a QR code where you can scan and it can take you directly to the page, directly to the live that is associated with it. Okay, so those are Audrey's notes. But I do have a left-handed version of my notebook. And welcome to my lefty session. So I got you guys all the things that we have, all the resources that all the other books have, you have that as well. So this is my lefties for my Pre-Algebra and Algebra 1. And I'm just waiting for my Algebra 2 and Pre-Calculus books to come in so I can share that information with you. All right. One, thank you so much for tapping away. So what we are working on, as I said, this is from the very beginning. So the one thing that a lot of people generally get incorrect is our terminology when it comes to certain properties. Now, the one property that a lot of us usually get wrong is called the commutative and the associative property. So we're also going to be doing distributive property and talking about like terms as well, but I really want to address this section. And this is going for not only for addition, but also multiplication. So, since my formula sheet is just a nice small little box, I figure, you know what, let me take it off to the side so we can really do all this investigation. Sorry, got all these things popping up on me. Don't care about that. Let's get rid of that. All right. I know. Had to take you on a little fantastic voyage for 5 seconds. Okay. So when it comes to the commutative, think about it. Commuting. Okay. When you commute, when you're making your commute from home to work back to home, or work to the bar, then home. Okay. Especially if you're a teacher, that's what we do on our Fridays. All right, leave us alone when we're out. So the commutative property, this is when you're commuting. This is when you're moving your numbers around. Okay, they're not losing their value. You're basically moving the numbers around so it'll be a lot easier for you to combine maybe your like terms. So if I look at it through addition, so when I have addition, I have 8 plus z plus 2. I know for sure I can definitely do the 8 and the 2 because those are my like terms. But through the commutative property, I can easily switch the 2 and the z. So now I have my 8 and the 2 next to each other. So now visually I can be able to combine them a lot easier. But even if I had my 8 plus z plus 2, it's still going to give me the same result when I switch my 2 and my z. So I can just do 8 plus 2 plus z. So my end result of this will be 10 plus z. Okay, my 8 and my 2, those are what's called like terms because they're both numbers. The z, that's a variable. Numbers, variables, two separate worlds. They can get close to each other, but they can't really intertwine. All right? Same thing is happening with multiplication. So if I do, and I'm doing the traditional with the x's because believe it or not, some of these exams are still using x's for multiplication. Why? Because it gets confusing when they go into algebra, okay? Because we like to use x as one of our variables. Now, boom. So if anything, we have 6 times 3. Now, 6 times 3, and if I do the commutative, all I'm doing is moving the numbers around, which is 3 times 6. It still gives me the same value. 6 groups of 3, 3 groups of 6. No matter how you switch it around, it still gives me an answer of 18. Okay, so commutative is when you are commuting. You're moving from one place to the next. Okay, got it? Awesome. Thanks, John. Now, the other part is the associative. Okay, to associate. So think of it this way. You know you have certain types of friends, right? You have your childhood friends, you have friends from high school, you have friends from college, maybe you have friends at your first job, you have friends at your other job, maybe some friends at your side business, but they're not all the same people. But it's when you do an associative, it's almost like you're mixing, say, your childhood friends with maybe your work friends. Maybe you have a work event and you're like, you know what? I really want my friend, Desiree to come with me. So you bring Desiree. Desiree doesn't know anybody at this work party, right? But Desiree seems like a type of person that will really mix well with people, right? I have some of my trifling ass friends that just will not mix. They're great for going out. They're great for socializing. They're great for, you need someone to ride or die right now? You're great for that. But when I want you to meet some of my work friends, no, okay? Definitely not. So this is what is happening when you're associating. You're associating one part, right? Exactly. You're associating one part of your world to another, but you're still the same people, okay? You're not changing your ways. So if I look at it for addition, I have 12 plus the sum of 8 and c. So if I move those parentheses over, it will still give me the same value when I have the sum of 12 and 8 plus the c. Okay? No matter which way you look at it, it still gives me that same answer of 20 plus c, or c plus 20. Okay, it's still going to give me that same answer. but it's how I associate it with them. And sometimes the associative property really stands out, especially when you have 3 type of terms versus sometimes the commutative, they use it with like 2 terms, especially with multiplication. But if you notice with multiplication with the associative property, you have 3 times 4 times 2. But they want you to do 4 times 2 first. All right, 4 times 2, that will give me 8. But I still, cringe with the thing, I still have to multiply the 3 with that answer. So 3 times 8, that'll give me 24. Whereas if I come over here, they want us to group the 3 and the 4 first. Okay, well 3 times 4, that gives me 12. And then if I multiply that 2, I still get the answer of 24. Okay, the value of the numbers are not changing. It's just how you associate it with. Okay, I want to hang out with my, I don't know, my high school friends, but then I have this other friend that is really cool that I think will gel perfectly fine with us. But she's not really in the clique. You know what I'm saying? Like, we're close, but you haven't been in the trenches with me, right? But you understand the good side of Audrey, but you haven't seen the thug side of Audrey just yet, right? So that's what the difference of the commutative, commute, place to place, whereas associating different types of grouping. All right? I think they're both right. Yes. So it's either going to be one or the other. And here's the thing. It only really happens with addition and multiplication. Okay? Not division or subtraction. Okay? No. Okay? The only you get the commutative and the associative with addition or multiplication. All right? Not a problem. Because I think a lot of us were always told, including myself, was always told that, okay, this is the associative property, this is the commutative property. But no one really explained it. But yet, these terminologies are always used in SATs, ACTs. I think I saw one on the IBEW for the apprenticeship of being an electrician. It's on their exam. And it was always mentioned on the GED and also the ASVAB. I saw one question, or somebody was talking about it on one question. Fairly recent, about like a couple months ago. All right. Hey, Danny, how are you? Who was Chuck Norris? Girl, look that up. There we go. All right, so let me unshrink. Let me put a couple examples out here to make sure that you guys understand. So I want you to either put a C in the comments for commutative or an A in the comments for associative. That's all I want you to do, okay? This should not be like forever brain breaks. So if I have... Okay, so first one. Actually, we should take it to the next level. C and A, that will work. And then maybe a plus sign for addition. And I don't know, maybe a star for multiplication. If we need to dig that deep, let's go. Let's try. All right. You're scared of Chuck Norris? Why? Okay, so I'm getting an associative Hey there, Madam Gadgets. What we got? What's first? Okay, they're both the same thing. So you need to tell me which property we got here. Thank you, Motor City. Appreciate it. Okay, so mathematics, and I can't read it. I want to say mathematics fan. It's saying associative. Okay, Danny said associative. She's a little confused. That's all right. Said associative. She's a little confused. That's all right. Okay, so with associative, is it addition or multiplication? Is it addition or multiplication? It was a little late. That's all right. All right. So we want to know which of these properties. Let me unzoom a little bit. Okay. Which of these two properties? Is it commutative? When you think about it, you're commuting. All you're doing is just moving things around. So for example, for the addition, we don't have any parentheses. Okay, all we did is just move some things around, move the numbers around so they're close together so we can get our final answer. With multiplication, all we do is just switch them. Okay, so that's going to be commutative. Now, associative is when you're mixing groups. Okay, you got one group and now you want to introduce them to another group. So like, okay, this is my work friend, but these are my childhood friends. And I thought my work friend would actually work pretty well with the group. But notice that she works really well with this person. All right, so now they bonded. Okay, and this was me left out in the cold. I'm like, I put y'all together. But no matter what, when we go and hang out, everything is going to be copacetic. Regardless if we were hanging out, just me and this person versus these two people. Okay. All right. Hello, God is good. How are you? All right. So this is associative. Okay. When they're bringing those parentheses in, that's kind of like a little hint. Okay. So when they're bringing that associative, it's bringing those parentheses. So this is definitely associative. I'm going to put an A. And what operation they're doing? They're doing addition. Okay, so associative with addition. I'm just going to say A+. All right, so let's see if we can get. Okay, well, you just got here, so obviously you're not going to know what's going on. So stop with the tear jerking and let's just sit and observe. Okay, observe. So if I give you if I said okay, is it commutative or is it associative? Now, if more and more people are coming in, okay, more and more of us are coming in. So Jess is saying commutative. Okay, Dom's saying commutative. All right. Is it addition or multiplication? Which one is it? Okay, Snaked Python is saying commutative. Okay, Big Al saying commutative. All right, I think that's supposed to be multiplication. But there are any operations, there are any operations that are commutative but not associative, and vice versa. True, but I'm just doing the basis of the basis, mathematician. Okay, all right, through multiplication. Good. All right, so all we're doing is just doing a little bit of switch, doing a little bit of flop. So we got our C, and since we're doing multiplication, I'm not doing the X anymore. I'm going to use a little star for multiplication. Star, the dot, or parentheses, something, something. Okay. All right. So how are we feeling? Okay, through multiplication. Good, Snaked Python. Love it. All right, how are we feeling about that? Okay, once we get that down, everything is going to be kosher. Okay, and a lot of people is just basic on that not multiplication, that terminology. That's what shakes a lot of people up. Now, I had a client today that this was making me crazy, and I'm like, dude, this is why I think school should go on all year long. Prime example. All right, so if you want, let me see if I can open it this way and be able to get as much as I can in here. Let's see if this will work. And if not, I might have to do it like this. All right, so continue to tap as best as you can. I greatly appreciate it. Let's see if I can unzoom. And it's not the zoom at all. Sorry for all this moving and grooving, but this is what I have to do. Just try to fit as much as I can in. So, we worked a little bit with the commutative. We worked a little bit with the associative. So what we're going to work on next is distributive. People, please pay attention to this. Distributive property is in expressions. Those are those phrases where you don't have an equal sign. Distributive property is used for solving equations. Distributive property is used in geometry. Distributive property is in pre-algebra 1, algebra 1, pre-calculus, calculus, AP statistics. Distributive property is everywhere. Please, for the love of everything holy, pay attention to it. Because if you can't get the distributive property down, it's going to be a long, long road for you to become a nurse, for you to be in the military, for you to be a teacher, for you to be even like a physician assistant, an apprentice. Trust me. Multiplication is, I believe, is the key to mathematics. That fast addition. No more counting by sticks. No more counting on your fingers. No more looking at the ceiling like God is going to throw the answer into your brain. Stop it. Okay? We really need to get our multiplication tables down. Okay? I don't know how you want to do it. It might be flashcards. It might be one of those. There's a lot of games, video games that does nothing but multiplication on there. They might be counting by tens, but at least you're getting that brain ready and willing to receive information. All right? No matter what, you can do what I think it's called Cool Math. Cool Math has a lot of cool games on there to really get your addition, your subtraction, your multiplication, your division down packed in a fun and entertaining way. And trust me, if you have kids, that'll be a great thing that you can have a friendly competition on who can get the game done or win whatever level, and just do something together. Okay? Your kids don't need to know that you don't know your multiplication. You're working, you're developing, you're growing. Okay? Beautiful. I'm getting off my soapbox. All right, let me see what's going on here. Hello, everyone. Hello, user. All that. You were super late. All right. Thank you, Big Al, getting with the 50K, because this is not going to be a long live. I'm starting to get to the point that I love you all, but at the same time, I cannot keep staying up at 1, 2, 3, like last night, 4 o'clock in the morning. So my health has to come first. I love you, but if I'm dead, you guys will find someone else to watch, right? So there's no big whoop. We'll find someone else to watch, right? So there's no big whoop. Moving fast. All right, so here we go. First off, let's take a look at what I'm going to use as a term, okay? So we have 4x to the second power. Okay, let me see if I can get it all in there. There we go. See if the ghost will keep it straight. All right, so we have 4x to the second power. That second power is called your exponent. The x, that's your variable. That's not multiplying. This does not mean 4 times 2. No, that's why we really should not be using x's for multiplication, as I did 5 examples on the other page. But the x is your variable. X can be any number. It could be 1, it could be 2, it could be 568, it could be positive, it could be negative, it could be a fraction, it could be a decimal, anything. Okay? So, because of that, because a lot of teachers will say, oh, if you just see x by itself, they say the x is 1. No, the coefficient in front of the x is 1. So many students get it all like, well, x equals 1. No, x equals any number. But that's what sometimes you're looking for. All right. And I know teachers, that some of you guys pop in here, especially as the school year comes around, because I've been doing a lot of, how should I say it? Math emina. Just give a little emina. Just whoosh, just it. Because I'm trying to wipe it out. Like no x for multiplication. Because then when they get into Algebra 1, all of a sudden I'm seeing 4xx. This is not porn. We're not doing that, right? We only need one x, and that x is a variable. That x does not represent multiplication. So the variable is my base. The 4, that's my coefficient, all right? So when we're looking at this, we need to identify what's called like terms. And I mentioned that on the other page, especially when we had that 8 plus 2 plus z. And I said 8 and 2 are like terms. Now, like terms that have identical variable parts, okay? So when I'm talking about that, I'm saying they either have the same variables and they have the same exponents. So you're basically playing what's called a matching game. Remember the matching game? Okay, I'm going to show my age. Here we go. There used to be a matching game where there used to be like little cards. One card would be an apple, another card would be an orange, one card would be like a famous person or like a singer. They'll just have different cards for different situations. You have them flipped over, and it's basically memory. You flip, you get an apple. You flip, you get a pear. You cover it over. You cover it over. Next person. They flip, they get a pear. Oh, where did I find the other pear? Oh, the other pear was here. They flip. Okay, they win that section because they matched up the two pairs. Same thing is happening when you're combining like terms. Okay? Good stuff, right? Going back in the old days, right? Same exact thing is happening. So let me share with you a couple examples and see if I can zoom in for you. I know, it's like all kinds of complications right now. Zoop. There we go. Okay, maybe not that much. We don't need to see what the paper was made out of. All right. So if we have example number 1. So if I have, let's say, 7x plus 5 minus 3x. Okay, so 7x plus 5 minus 3x. Well, right away, I'm looking for same variable with the same exponents. So if we got the same variable with the same exponents, that means my 7x and my minus 3x are like terms. Okay, they're my like terms. So if I want to combine those like terms, all I have to do, here I go, let me commute it if I want to. I'm taking this step by step. Okay, I'm talking to those people that are just like, you know what? Math has always been an Achilles heel for me, has always been a problem. So why not take this negative 3x, do my commute, put it in front of that 5 or that plus sign. So now I got 7x minus 3x. And after you do this for a while, you can probably skip this step. But I'm trying to show you, remember, today is back to basics. Okay, starting all the way from the very beginning. So with that, I notice I have my like terms close to each other. So if I have 7x's and I subtract 3x's from it, that will give me 4x's. All I'm doing is subtracting or doing the operation for the coefficients. The x comes down. So if I say I got 7 watermelons and I sold 3 of them, that means I still got 4 watermelons left. I'm a little hungry and I bought watermelon today. So there we are. Okay. So then this plus 5, you do not add it to that 4x because that 4 has an x and that 5 doesn't. So you can't combine them. This is what's called unlike terms. Okay? They can get close, but they can't date. All right? These two, they just say, oh, we have so much stuff in common. Let's get together. Yeah. And then you had your 4x. Okay? This is your answer. Okay? So I know some people are like, Audrey, you went a real long roundabout answer. Just do this and this. Yes, but there's a lot of people that don't know how to do that. And you know why I know this? Because I've been tutoring most of the day with people that don't know this. So that's why I'm here at night at 10:03 Eastern Standard Time breaking down these concepts. So please, hush. Thank you. All right. Okay. Of course. But I need for you to say nicely. All right. Good, Sharon. Good. Not a problem. All right. So here we go. Hopefully I'm not too cockeyed for everybody. So we have our next example. Hoping that you guys can see it. Oh, that'll work. Okay, so we have 6x. I know I can use other variables, but I just want to start off small in the very beginning. Okay, so we have 6x plus 4 plus 15 minus 7x. Okay. Oh, thank you. All right. Okay. How did I get this problem? I just, collecting. All right. So, here we go. If I want, I can look at my like terms. I'll use the ones. I don't have another highlighter, so. Plus, I don't want this book to be like illuminating at night. So, we have our 6x and we have a minus 7x. Those are like terms. Then, I notice I have my positive 4 and my positive 15. Those are another set of like terms, right? What's the problem? Oh, okay. That's all right. So now we have 2 sets of like terms. So we can do our commutative property, all right? Move things around so it'll be easy for us to do those combining of like terms. So if you want, we can say, all right, I'm going to have 6x here. I'm going to move my minus 7x. You always move the number and its operation. Then you can just bring down your plus 4 and your plus 15. As I'll say again, after a while, you can probably skip this step. Once you see it and identify it, trust me, as you keep training yourself, it's going to pop up. And you're going, oh, this is so easy. So now we have two sets of like terms. The family of x's and the constant. So for the family of x's, we have 6x minus 7x. So think of it this way. Are you ready? You have $6. You want to buy something that's worth $7. Guess what? You're short $1. Okay, you're short that dollar. Now I have $4 and my friend gave me $15. Oh, nice friend. Because now I have positive $19. Okay. Yes. So we can not combine these two. All right. And if I want to, I can kind of clean it up. I can leave it either as negative 1x plus 19, or you might see this, negative x plus 19. Okay. Any one of those two will work. Okay. These two things are basically meaning the same thing. Remember I said earlier that, if you don't see a number in front of the x, it's assumed to be a 1. Look at that. That's what I'm talking about. The x isn't 1. X can be any number it wants to be, but its coefficient is what's 1. In this case, it's a negative 1. All right. We're feeling all right? Okay. Trust me, I got more. There's plenty. We're not just going to stop right here. Let me take it a step further. Okay, so here's the thing. I love that you're thinking dividing negative 1 on both sides. So here's the thing. We do not have an equal sign. So since there's no equal sign, there's no two sides. It's just one big old side. Okay? Just one big old, just one side. So I'll try to keep it clean. All right? If there was an equal sign and we're solving for x, yes, you want to divide negative 1. But since we're not solving, we're doing what's called simplifying. So when you don't see an equal sign when we're starting, we're just simplifying. But if there is an equal sign, that's when we're going to be solving, and then you can divide by negative 1. Okay, not a problem. But you're thinking, I love it. I love it. I love it. I love it. Okay, so there'll be no solution. So right now, we're not solving. We're just simplifying. We're just breaking it down into its simplest terms. That's all we're doing. Okay? All right, good. All right, so let me step it up. You're so welcome. So this is what I want you to do on my lives. I want you to ask the questions. It's a safe space. If someone steps out of line, trust me, I'll break them down a little bit. It's usually entertaining to do so. So if I say this, so 2x squared minus 3x, you're probably like, oh God, Audrey's trying to do, no, breathe. It is going to be something, but you're going to be able to do it. And think how amazing you're going to feel once you're like, oh my God, I got that. That wasn't too hard. Watch. Watch. Let me see, am I getting everything in here? Okay. Yeah, I'm a Philly girl. All right, so we have 2x squared minus 3x plus 7 minus 3x squared plus 4x minus 7. Okay. Yes. Is it Dami Lola? Collect the like terms, then not solve. Collect the like terms, then simplify. I know, I have to correct you on that. I'm sorry. But I know exactly what you were saying, but I definitely want to make sure you guys understand that part. Okay? There is no equal signs. None. If there was an equal sign, we're solving. Since there isn't any equal signs, we're simplifying. So, let me start with my highest exponent. My highest exponent is to the second power. So I have 2x to the second power, and that's matched up with negative 3x to the second power. Okay? The reason why these are like terms, because both of them have x to the second power. All right? Okay? Both of them have x to the second power. So don't go crazy adding. Oh, there's all these x's. Let me just combine all of them. No, just calm down. Getting crazy. All right? So we know that these two are like terms because the variable or the base and the exponent is exactly the same. So now I can say that this negative 3x and this positive 4x, they're like terms. The reason why, they both have the same variable of x, and exponent is usually a 1. Again, if you don't see a 1, there is a 1 there. All right? Good. I'm seeing a lot of cool answers, but I'm seeing some tweaked answers we got to look at. So, but that's okay. That's why we're here. Now, we have a positive, probably see if I can make it into a square kind of. We have a positive 7 here, and that's matched up with this negative 7. Okay? So I know it looks like a hodgepodge of craziness, but if you take it step by step, it's not going to be super overwhelming. So if we take a look, we have 2x squared minus 3x squared. You have $2. You want something that costs $3. That means you are short $1. And notice I am not adding the exponents. When you are adding or subtracting, you're doing nothing with the exponents. The only time you do something with the exponents is when you're multiplying or dividing. Okay? So we're not doing anything. Perfect. So when I'm done with them, I cross them out. Okay? That's how I keep track of this. The next ones are going to be my x's. Not my x's, but the x's on here. So we have negative 3. And we have a positive 4. So we can think of, I have $4 and I spent $3. That means I have $1 left. If I have $1, that's a good thing. Plus. So that'll be plus 1x. Or x. Okay. Good, Big L. Now, we have a positive 7 and a negative 7. So if I have a positive 7, I have $7. I spent $7. I'm broke as hell. So guess what? I could put a plus 0. But 0 is a placeholder. Okay, so if anyone's ever told you, okay, you need something, 10% of nothing is still nothing. But 0 is a placeholder. I don't have to put the 0 if I already have some other elements down here. Okay, so if I want to clean this up, I could say, I'm going to write the word or. You can have this as your answer, or I can say negative x squared plus x. Okay, so either one would work. And the reason why I'm showing both ways is because sometimes, well, most tests won't have a plus 0. I'm just going to tell you that right now. But sometimes I've seen some exams, especially GED, they have like a 1 in front of the X. And I'm like, wait, why? And sometimes it's not there. So at least when you get the exposure of both ways, you'll train yourself. And before you know it, you're going to do well on those assessments. All right? Yes. Okay. So understand. I try. Thanks, Jess. Thank you. I know. Sorry, my camera work tonight is a little off. It's really hot in this room, so like things are like melting off the walls. It's like hilarious, but yes. All right. Okay. Would you like another for like terms before I go into distributive property? Would you like another for like terms? Okay, just saying yes. You think you're getting it? Yes. Yep. All right. All right, keep on tapping. Let's see if we can get to like 35, if not 37. There's 160 of us. We can do a quick mad tap. Don't be selfish with your love. Don't be so selfish with your love. I should see a whole stream of hearts. Let's go. Keep it going. Because the more that we tap, the more it's telling the algorithm, like, hey, we got something here that people need to see. I mean, it's not my ego. It's just more so that I really and truly want people to get that advancement. Because a lot of people don't know. You guys are like, Audrey's the best kept secret. We want to keep her to ourselves. Gotta share them with the world, people. Gotta share them with the world. Okay, almost at 35. We'll be back soon. Okay. Thank you so much for sharing, Sharon. I appreciate it. Everyone that has been sharing and I haven't been addressing you guys, I'm so sorry. Just been focusing on the math right now. All right, awesome. That will work for me. Great. Thank you. So 12x minus 5 plus 7x minus 11. Okay. So here's your next example. Well, thank you, Erica. Yes. All right. Give it a try. Let's see what you guys got. Yes, this is a 12. So we have 12x minus 5 plus 7x minus 11. Okay, so 12x minus 5 plus 7x minus 11. And all we're doing is combining our like terms. Johnson's saying 19x minus 16. Ronnie's 19x minus 16. Quad says 19x minus 6. DC Dude 72. Oh, I was born in 72 too. 19x minus 16. Okay. Pretty Black is saying 5x minus 6x. Where are you getting the 5 and the 6 at? Oh, okay. I see what you're saying. All right. Ave is saying 19x minus 16. Snake Python 19x minus 16. Pretty Black 5x minus 6. Jess 19x plus 16. Is it Nikita? Is 19x plus 16. Simplify more or not. Okay. User is saying 19x minus 16. Shars 19x minus 16. Danielle S 19x minus 16. Is Adara saying 5x minus 6. Sharon 12x minus 7. All right, we got a nice collection. All right, so first, if we want, we have our 12x plus our 7x. And if we want to do that commutative property to really bring them together, we can do that. So that will be my 12x plus 7x. We can do it that way. And then what we have here, we have our negative 5 here and our negative 11 here. And if we want to do the associative property with them, that'll be minus 5, minus 11. So we can get our like terms with the x's together and then get our constants together. Now, we're going to combine the two. So now we have 12x plus 7x. So 12 plus 7, that will give us our 19. And we just bring the x. So I was happy to see no one said x squared because we're not multiplying. When we multiply, we add the exponents. But when we're adding and subtracting, all we're doing is using the variable with their degrees or exponents as matching. So we're playing a matching game. So that takes care of our x's. We all know how we want to take care of our x's, but we're moving on. So now we have a negative 5 minus 11. So this is like a person that's a little down on their luck, right? You borrowed $5 from me, and for some sick and twisted reason, I loan you $11, okay? Haven't paid me my money back, right? So you owe me $5. Then for some reason you asked for another $11. You needed to pay a bill, you needed some money, some food, whatever. So now you still owe me $16. Okay? The only time that a negative and a negative changes to a positive is when you're multiplying. We're not multiplying right here. Okay? We're combining. When we're combining, and this is the easiest way for me to remember, when they're both negative, that means I'm adding them together. When they're both the same signs, I'm adding them. When their signs are different, one is, let me see where I can get it from, probably this one up here. When we had the negative 3x and the positive 4x, the signs were opposite. So that means I'm subtracting, okay? When the signs are the same, I'm adding, okay? All right. Okay, if you want me to do geometry, hire me as a tutor. It's really that simple. I'm more than willing to do that. And plus, I've done all those. Okay. Can't leave any more money to... I don't have to be a deadbeat. Well, if it was my exes, yeah. Okay, so you were close. Okay, all right. But do you see it now? Like, don't just sit there and beat yourselves up and say, oh my God, I'm so wrong, I'm stupid, I'm this and that. No, you're not stupid. Stop. Okay, give yourself some kind of grace. All right, one, has anyone ever sat down and broke it down to you like this? No. You were in a classroom with 20, 30, sometimes 40 kids in one classroom with one teacher or maybe two teachers in there, and you didn't want to cause any attention to yourself, so you just sat there quietly. And the teacher's like, oh, you're such a good person, you don't give me any headaches, but yet you're not learning because you were holding yourself back. So give yourself grace, okay? Please. All right? That's why we're here. We're here. We're going to move on. All right? We're going to change this. I'm looking at it. Right. You know, just take your time to really look at it. All right? Okay. No, don't cry. I mean, the tears are going to shed because I had them. I had some really good teachers, but I had some awful teachers, or just teachers that are just trying their best. And it's not for me to bash teachers, because I used to be a teacher. Like, you know, I used to be in the classroom. So I went through the trenches. But I understand, like, when things are thrown at you and you have kids and you got one kid that wants to climb the wall and be Superman, then you got another one that's taking their spelling book trying to kill a bee and all of a sudden breaks the glass. Then you got another one throwing pencils across the room. Then you got this other one putting on more shades of lip gloss. How much lip gloss do you need, girl? Like, you got 2 lips. So that's it. That's all you need. So it's like you have this mixture, but you don't want to call yourself out. So please, this is the time to just ask the questions that you always wanted to ask. Okay? This is a safe space. Ask it. All right. I try. Trust me, I just explained a whole lot. Now, combining like terms, I'm going to take it one step further, and then that's it for tonight. I know. And that one step further is called the distributive property. So I'm going to break it down as best I can. And I'm actually going to use another page. Why not? I got like 100 and some of these pages. All right, so I'm going to use it over here. And if you guys can continue to tap, I would greatly appreciate it. Like 50K would be amazeballs. Would be amazing. So I'm just going to write continued here. And I'm going to say... Now, the one thing you need to know about the distributive property, the best thing I can say is, let's say you get a large order of fries, like delicious boardwalk fries. They are fried to the crisp. They have the crunch to it. You can still see parts of the skin. Like, it's just delicious. All kinds of delicious. So you and 4 of your friends are out, okay? Now, if you get a plate, or let's just pretend it's a bowl of fries. I know, I'm really reaching here. And you have a couple friends. Got this person, got this person, got this Joe Schmo with the hair swoop. and the crazy pony. You know, you always got that one friend with the ponytail. Can't see from one eye. Like, why you got all this hair in one eye? Like you a pirate or something. All right, so you got her. And then you got this person. And this is you. Okay? I know. Picasso, right? Well, thank you for reaching my little goal. All right. So now, when you have your fries and you want to share your fries, you need to share your fries to everyone. Because if you only share to 3 out of the 4, you guys gonna have some problems. Because, you know, that's gonna be a long car ride home or a train ride home. You don't want to hear that person's mouth. All of a sudden, years down the road, they're like talking about, oh, I'm getting married. And then you don't get an invite because you didn't share your fries when you were in 8th grade. Really? Are we really that petty? Yes. They're really that petty. Okay? So to eliminate that, okay, you need to share to everyone. Make sure everyone gets a nice amount of fries. All right? Same thing like maybe you're having an ice cream social. Making sure that if you guys have kids, trust me, try not giving, like, say you have those gift bags or like even Halloween and especially Halloween, and you give candy to this kid, to this kid, to this kid, and you accidentally ignore one kid and you saw another kid and you just gave to them. Look at that child's face. It will be engraved in your head. The disappointment that this person has. Right. So you need to share. That's what distribute does. You want to share. If 5 people went in on a lottery ticket and you won the lottery ticket, guess what? We splitting this 5 ways. If not, we got some problems, right? So the same thing is happening when you distribute. So when I have a distribution, I'm going to say 2 times, example. Okay, so I'm doing 2 times x plus 8. Okay. So when I distribute, I have to distribute to everything inside of this parenthesis. Okay, that's why when you see a lot of people talk about distributive properties, that's why they do these arrows. We don't do these arrows just for, shits and giggles, right? Like, we just want to draw a rainbow. No, we're doing it to have it as a reminder that when you distribute, you're multiplying. And you're multiplying this 2 to everything inside that parenthesis. If I need to write it out, this is what it looks like. It looks like I'm doing 2 times the x plus I'm doing 2 times the 8. So when you clean this up, 2 times x is 2x. Okay? You do not have to keep the parenthesis around it. Okay? If you want to clean it up. Plus 2 times 8, that gives me 16. So here's my question. Is 2x and 16 like terms? So is my answer really 18x? Yes or no? Yeah, you made it. Good. No, I love it. No. Addicted to success. No. Good. 2x plus 16. No. No. 16 over 2. We're not dividing. Okay, so it'll be no. Okay, we don't have any negative numbers here, so it can't be a negative 8. Try again, okay? So, and x is negative 8. Well, we can't say x is negative 8 because we don't have an equal sign. There is no is. Is means equals. We don't have an equal sign, so we're not solving. Okay? Try another. So that is your answer. All right? So let me step it up just a hair. So if I have 7x plus 3 times negative 2x, you're probably like, oh, she's still going. Yes, she is. Plus 3. Okay, let me slide that over. So 7x plus 3 times the sum of negative 2x and 3. Okay. Okay. So let's take a look. Just like PEMDAS. Remember PEMDAS? Please excuse my dear Aunt Sally from left to right. That's the part that everyone misses. From left to right. Okay? Cannot forget that. Now, if I have, which I have to get used to my new version of this. Okay? Some of you guys might be international. Okay, so you're used to this, badmas. Okay, I don't know if it is, but it's very much the same with some kind of twist when it comes to, please excuse my dear Aunt Sally. So we're still dealing with the parentheses or the brackets. We're looking at the exponents, which you guys like to call the order. Then we multiply or divide. You guys divide or multiply, but we agree with the addition or subtraction. Okay? So some people are good with PEMDAS, some people with others. Regardless of it, in order to be successful in this, okay, we have to take care of the multiplication. We don't have anything inside the parenthesis for me to combine. Okay, so there's nothing inside the parenthesis for me to combine. They're not like terms. I don't have any exponents. Okay, so I can cancel that out and cancel that out. But now I have multiplication. There is no division. So this positive 3, I am distributing to everything inside that parenthesis. Okay, so for right now, this 7x is just coming down for the ride. But I need to multiply. So a positive 3 times a negative 2x, a positive times a negative gives me a negative. 3 times 2 gives me 6, and we only have the 1x. Now I'm distributing the 3 to the positive 3. Positive times positive gives me a positive. And 3 times 3 gives me 9. Okay. All right. Okay. Why am I not putting equals on it? Because we're not working with equations yet. We're just dealing with expressions. So now I have my like terms already set up for me right next to each other. How convenient. So we have 7x minus 6x. So we had 7 peaches, We sold 6 peaches. That means we got 1 peach left. And that plus 9 just comes on down, because it doesn't have anything to combine with. And basically, this is our answer. 1x plus 9 or x plus 9. Okay. All right. I know. Oh, wait. Someone had a question. Sorry, Fishing Phil. If there is 3 sets of parentheses being multiplied, the order doesn't matter. True, because of the commutative property. Yes. Yep. So if I had 3 things, well, not commutative, associative property. Almost got me there. Okay? So if you have 3 things being multiplied, if you had all 3 of them had their individual parentheses around it, like you said, it doesn't matter if I multiply the 3 and the 4 first or I multiplied the 4 and the 2. Okay? No matter what, you're still going to get that same answer of 24. So yeah, so that's going to be with the associative, not the commutative. Yes, I know, Phil. Trust me. That's why I'm doing this tonight. Because including myself, I get kind of caught up with it. So do not. Don't even stress. So does the x plus 9 show a y-intercept on the graph? It doesn't show a y-intercept because it's not a linear function. Okay? You're getting everything all mixed up, my dear. Okay? Getting it all mixed up. So it cannot be... x plus 9 is not, it's not a linear function. It's not a line. Because there's no equals. Okay? Yep, there's no equals. All right. Hello, Joel. How are you? Okay. Aw, hey, oh my gosh, today was Wednesday. Oh, sugar, I forgot it's live. I'm hoping I can see it. All right. Can you explain again? -5, -11, y it's -16. Sure, Jess. So since we have, so like if that person borrows $5 from you, okay, so say I borrowed $5 from you. And then all of a sudden I come over and I say, yo, Jess, man, I suck at this. Can you loan me $11? Even though I know I owe you $5, but can you please spot me $11 if you have it? You have it, you give it to me. Now, I owed you $5 from before. Now I owe you another $11 in addition to that. So that means I really owe you $16. Okay. Okay. You just finished Algebra 1. You don't know why you're in this live? Well, I'm glad you're here. Oh, yeah. No, quadratic, that's going to be when your x is squared. Okay? So right now, we're not even going on that road just yet. Yeah, we're starting from the very beginning. But welcome in. Did that make sense, Jess? So when both numbers are negative, your answer is going to stay negative. You're actually adding them together. When you're multiplying, a negative times a negative is a positive. So we were just combining. When we're combining, we're adding. Okay. Okay, so when you're combining, you're adding. And they're both going to stay negative. Yes. I know. There's so many rules. I know. It's almost like, oh, your mom and dad is letting you throw a party in your house. But then there's so many rules. We don't want anybody here. We don't want anybody upstairs. You're like, well, what's the whole point of the party? Yeah. So let's try this one. So we have 4 times 2m plus 3 plus 6m plus 5. Okay, hey, period. So period saying 14m plus 8. And Chris is saying 14m plus 17. Ooh. Okay, period went to 14m plus 17. Addicted to success. 14m plus 17. Jess saying 16m plus 8. We have to do everything in the parentheses. So then you have your, you got to distribute everything in the parentheses. So we have 14m plus 17. Ronnie, 14m plus 17. Slick, 14m plus 17. My DC dude, 14m plus 17. Danielle, 14m plus 17. Lumas, 14m plus 17. I am Quad, 14m plus 17. Just switched over to 14m plus 17. My day was okay, period. I appreciate it. Okay. Nas is saying 14m plus 17. There you go, Nas. Welcome to the party. All right. All right, so Courtney was saying 14m plus 17. We can catch on. But see, that's the best part. So as you guys are closing up, Ryan saying 14m plus 17. Awesome. So just in case you guys can't really stick around or you want to see the replay of this, you just go here, because I can't say the name. You go here. You can type in either my name, which is Audrey Codner, or ACG Math Tutoring. And then you'll see a playlist that says TikTok lives. Okay, I would love for you to do this. I would love for you to subscribe. The group is growing dramatically. I love it. If you want to like some stuff, you can like it. I want you to comment. I want you to share, especially if you know people that are struggling with the foundational pieces of algebra. So GED, ASVAB, maybe even just homeschooling. Maybe you're a teacher, want to get some ideas. I don't know. Have fun with it. I'm not bougie yet, so you might as well get all the information you can now. All right. Okay, so let's get with it. 1, we have this 4, and we need to distribute to everything inside of its own parenthesis. Just in the parenthesis, okay? Don't go crazy over here saying, oh, let me multiply everything by 4. No, calm down. Just the parenthesis. So this is what's happening. You're doing 4 times 2m plus 4 times 3. And then we're bringing down the plus 6m and the plus 5. So, combining. Let's do our multiplying. So we have 4 times 2m. Okay, that gives us our 8m plus 4 times 3. That gives us our 12. And then we're bringing down our plus 6m and our plus 5. So now from here, you either could just highlight and say, all right, where are my like terms? Here's my 8m and here's my positive 6m. They're like terms because both of them have the variable of m. Now, we have our positive 12. That's supposed to be a plus sign. Kind of overshot it. And our positive 5. They're like terms because they're both your constant. All right? So, if you want, you can do the commutative properties, which is moving things around so you can see your like terms a little bit better. You can definitely do that. So if you want to do 8m plus 6m, then add your 12 plus your 5, you can do that once you start getting comfortable with, boom, I can go straight here and add them together, okay? But if you rather group them, do it. Do what makes you happy. So 8 plus 6, that gives us our 14. Okay. And then our 12 plus 5, that gives us our 17. Almost had a brain fart for a second. There we go. PTSD. See? Yes. And you can't combine those two because that 14 has an M and the 17 doesn't. All right. Yep. You don't simplify anymore. There's nothing to simplify. Okay. GRE tutoring? Yes, I do. Just go ahead and message me. Okay. Love the distributive property. So do I, Betty. BJK. I'm just going to call you Rover if you don't mind. Don't worry about the PTSD. Trust me, I think all of us at one point in time when we saw math, I know for sure when I saw fractions and word problems, I was like, hell no. No, not doing that. I sucked at math, guys. Like, I seriously, each and every day, I'm like, God, you wanted me to be a math teacher. Because my early experience with math, sucked at it. Oh, I don't even know how I became a math teacher. Seriously, there's times I wonder. Like, I really don't know. Right? Like, how did this come out of it? But I think it's because you're preparing for the GED. Yes. Please, guys, I know these extra services that I do, the tutoring, there is a charge for it. And I do have a special charge for TikTok because I take a lesser amount from TikTok because you guys support me so much, more so than anyone else. So I usually have the outsiders pay a little bit more than my TikTok people. But if we get a group, if you're getting yourself ready for your GED and you want to do a mock test, I have a couple mock tests that I created to help with those things, because a lot of the concepts that you need help with is exactly the same for GED, ASVAB, ACCUPLACER. What's the other one? TEAS, the algebra part of the TEAS test, the IBEW, which for electricians, you know, is basically the same math concepts. Exponents, dealing with polynomials, dealing with quadratics, factoring. It's the same thing. Algebra 2, or I'm sorry, the SATs go all the way up to Algebra 2. Like, guys, I'll help you. Just let me know. So when did you start understanding math? Until I was like 25 years old. And I sat in the math classroom. I was an instructional assistant at a local high school. It was my first year. And all of a sudden the teacher just says, guys, fractions is nothing but division. That's all she said. And it was like, bing, a light just went off. And all of a sudden I'm like, oh my God, like 1/2 is 1 divided by 2. You would have thought that Jesus came down and said, what's up, girl? Like, it was just like, it was like the best thing that's ever happened. And it just stuck. And then I started watching some teachers, and not the teachers that were awful, but there was some good teachers at that particular school that I would sit and I would watch and see how they taught and see how their students reacted to them. And then I went to another school, and then all of a sudden I got thrown into teaching. And I had to learn the concepts. So I had to take classes. I had to learn from my colleagues. I had to see what worked with some kids and what didn't work with other kids. And of course, I did well with a lot of special needs kids because of the way that I break things down. So it just all goes, hey, Miss Adventure. Yes, but see, here's the one thing about self-teaching. You can teach yourself incorrectly at the same time. Because who's going to check you? Who's going to challenge you? Who's going to push you? Who's going to tell you, okay, the process is right, but you forgot something. You can easily convince yourself. You can easily look at the back of the book and be like, oh, the answer is 4. Yep, I knew that. I knew the answer was 4. I knew that answer was 4 from the very beginning. Because you know what? This is what you got to do. And you sit there convincing yourself. No one else is in the room, but you're like, but this is what you got to do. See, once you got to distribute that 4, because if I don't distribute that 4 to everything, it just messes the whole thing up. Convincing yourself big time. Yep. Sometimes, just that one teacher, you have no idea. All right. Well, thanks, Jess. All right. Okay, answer me this. Would you like to see one more? Because 11 o'clock, you're just going to be like my cow. I know. But then here's the best thing, period. Because I know a lot of us do this, is when we check the answers in the back of the book, most of the time we have no idea what those answers mean. We'll look at there like, what are you saying? Like, what does that mean? Domain. What? And especially if you haven't heard the word domain used in the math terminology in a long time, you're going to be like, oh, wait, what's the domain? Like, what? Why are all these numbers here? And it just frustrates you so much. So that's why I'm working on, my current thing is working on a math workbook that heals all of these concepts that I'm doing now, but actually have a more interactive answer key. No one has an interactive answer key. I'm going to. There it is. Oh, good. So why is it did? Why is it not continuing? All right, Jay. All right. All right, Jason. I got you. I'm here till the good Lord takes me. I'm here. So, okay. So I had a couple yeses. One more. All right. So, I'll see if I'll make it a little challenging, but not too crazy. I'm going to make it crazy. Just going to put all kinds of letters going on in here. All right, let's not with the red because I need the red. Let's see if we can do this. -4 times 1 minus 8x minus 9 times -10 x minus 1. Okay. Give that one a try. So -4 times the difference of 1 and 8x minus 9 times the difference of -10x and 1. Visualize with a bang. I know, right? Your last math class. That's awesome. Oh, you're in the U.S. now? All right. You can still tutor. If you're not, I mean, depending on what your job is, I'm only assuming. Chemistry. Oh, for chemistry, yeah. Yeah, self-taught in chemistry. Okay. All right, so we're getting a couple answers coming in. I know some people are like, wait a minute. Give me a second. And I got you. We'll just get some people some chances. Okay, be creative. Thank you for sharing the live. Thank you for sharing the lives and tapping, guys. I mean, my goodness. Over 66K? My goodness. Seriously, I cannot pay any of your medical expenses with the carpal tunnel. Guys like tap, 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 tap. There's got to be another way that they can do all this. Okay. All right, so I'm seeing we have Whitney with 5 plus 122x. Brandon saying 122x plus 5. Chris is 122x plus 5. Period is 122x plus 5. Courtney with 122x plus 5. Addicted to success. 122x minus 13. Okay, thanks for the follow. Danielle saying a negative 122x minus 13. Okay. Alright. I'm Quad saying negative 13x minus 58. Sharon's got 122x plus 5. Jennifer Brown's got negative 58 plus 5. Okay, Jess is 122x plus 4. Okay, Ma's saying 5 plus 58x. Quad is negative 13 minus 58x. Danielle switching it up with the 122x minus 13. Okay, just followed I need help. Okay. Definitely send me a message. Send me a message because I'll look in that, I forgot what it's called. Well, we're not friends yet. And just let me know what you need help with. Don't just say hi. Please don't. When you guys message me, I don't think it's you guys, but I just like to make this general announcement. When you message me, tell me what you need. Don't just say hi. Or put in a fake, you go to my website and then you put like a fake email or a phone number, and then I'm calling some random person. They have no idea what I'm talking about, because that's the time that I could have spent with a person that really needed my assistance. You know what I'm saying? Yeah, don't waste a moment. Okay, so user all of that, say 122x minus 13. Okay. Yeah, get me now before I get booked. That is so true. Because school starts in Puerto Rico on Thursday. I think Alaska starts on Wednesday. Florida starts this week. I think Florida starts this week too, right? Okay. Hey, Janice, how are you? All right. Please, I know. Okay, so here we go. I will see. So, first thing, we have that negative 4. So negative 4, we're multiplying everything in that first parenthesis by negative 4. So that means we have negative 4 times 1, and then we have our negative 4 times negative 8x. And I think a lot of people kind of got lost in the sauce right here. Then over here, we're taking this -9 and we're distributing that to everything inside the parenthesis. So that will be a -9 times a -10x, and then a -9 times a -1. I think the sign got a couple of people. So -4 times 1, that gives me a -4. -4 times -8, a negative times a negative gives me a positive. 4 times 8 gives me 32x. Okay. Now we have a -9 times a -10x. Negative times a negative gives me positive. 9 times 10 gives me 90 with the x. -9 times -1 gives me a positive 9. Negative times negative gives me positive. Okay. So we need to get our like terms. So right here, our like terms is a positive 32x and a positive 9x. So when I combine those two, 32x plus 9x, that gives me 122x. So we're done with those. But then I have this -4 and that positive 9. So -4 plus 9, that gives me a positive 5. Okay. I know, right? Yeah, because August 1st was yeah. GREs. Last time I checked, you are allowed to use a calculator, but a scientific calculator for GREs. That was the last time I heard. But I think there is a calculator section and there's a non-calculator section. But I know they changed the SATs and the ACTs with Desmos. So I needed to double check on, well, they did that for the past couple of years. So I need a double check of like Praxis and GREs to see if they changed that as well. Yep, the sign is what's getting a lot of you guys. Because when we're multiplying, because when you distribute, you're multiplying. When you're multiplying, when your signs are different, your answer is going to be negative. When you have a negative times a positive, that always gives you a negative. But when you have a negative times a negative, your answer is always going to be positive. So that's the rules of multiplying. Okay? So when I had my -9 times a -10, that gave me a positive 90. So -9 times a -1, that gives me a positive 9, not a -9. Because that's where a lot of your -13s that some of you guys were writing, that's where that came from. Okay, good. All right. So this will be my final answer because the 122 has an X and the 5 does not. So they are not like terms. Okay. All right. So if this is a little late for some people and you need to skedaddle and you're like, oh, I really want to watch the rest of this live, you don't have to torture yourself, my dears. Okay. You can come here. All right. If you go here, you can either go type in ACG Math Tutoring, or you can type in my name, Audrey Codner. Okay, one or the other will work. Let's see if I can shrink it so you can get both. All right. All my replays. Now this one, give me a couple hours because sometimes it takes forever to download it and then upload it there. Okay, so sometimes it might take early tomorrow morning. Like, I'm telling you, the struggle is real with this thing. All right, but I would love for you to subscribe. If you can like, comment, share, and also turn on the notifications. I don't go too crazy. I try to put at least like one video, which is my live, at least once a day. If not, I might do a little something extra with my shorts here and there. Okay, all right, so you got that. All right, love it. So you don't have to. I understand. Some of you guys have to go up early and go to work. I get it. All right, so let's try one more, and that's it. No más. Por favor. Let's see. Let's see if we can get something with, let's see, we'll put it over here. Because you guys are tapping like fiends, man. Just fiends. Did I do that one? Nope, I didn't do that one. Okay. All right, so we have 5 times negative 3x plus 7 plus 5 times x minus 1. So I'm seeing some answers. So I do see you guys. I'm just trying to give people some time to put their answers up. I love how you guys talk about me acting like I don't see or hear y'all. Like I'm in the classroom. They're like, man, our teacher's dumb. Hi, I'm right here. Got something to say? Say it to the face. All right. Okay. That's why I don't substitute. My God, I don't think I could ever even think about substituting. All right, so Chris, I remember you changed. You said plus 30. Okay, so negative 10x plus 30. Whitney has negative 10x plus 30. Addicted to Success has negative 10x plus 30. period, negative 10x plus 30. DC do, negative 10x plus 30. Okay, someone's saying AI. Then we have negative 10x plus 30. Is that sin? Then we have just with negative 10x plus 30. JF, negative 10x plus 30. Ma saying negative 10x plus 30. Good job, Ma. You can do it. Okay, Quad saying negative 20x plus 2. Okay, well, let's take a gander. So we are distributing. When we distribute, we multiply. So it's like saying 5 times negative 3x, okay, plus 5 times 7. Then when we distribute the 5 to everything inside of its parenthesis, the second 5, we have a positive 5 times x, and then we have a positive 5 times negative 1. Okay, just so you have the expansion, okay, so you don't have to do that. All right, so now let's get with our multiplication. Positive 5 times negative 3, that gives us a negative 15x. Okay, signs are different. My answer is always going to be negative. Now, my signs are the same. Positive 5 times positive 7. That gives me a positive 35. So here, again, positive 5 times a positive x. That gives me a positive 5x. And a positive 5 times a negative 1. The signs are opposite. So my answer is always going to be negative. Okay. All right. So now, let's get our like terms together. So we have our x's. So we have a negative 15x, and we have a positive 5x. Okay. If we want, we could do that commutative. We could commute things around to put our x's together. Eventually, this is what you're going to do. You're going to say, all right, I owe $15. I paid someone $5. That means I still owe someone $10. Okay? Think of it like money. When you guys think of it like money, it just makes things so much easier. So that means these are done. Now what's left is a positive 35 and a minus 5. So if I have $35 and I spent 5, that means I have $30 left. Okay, so we do have a solution of negative 10x plus 30. And I know you're itching. You're like, I should be able to factor this. We should be able to simplify it by pulling out the negative 10. Stop. Okay? It doesn't say for anything else to do it. We're just distributing. If it does, if you basically look at this and then you look at your answer choices and you do see a negative 10, and you do notice that they factored it out even further, and we can talk about factoring a little bit later. Actually, it's going to be talking about that later on. Then you can do it. But once you get to this point, you should look at your answer choices. Remember, most of these exams are multiple choice. If it is multiple choice, then you're looking to see which one is closely related to what you got. All right, the way you take your GED, the ASVAB, the ACCUPLACER, the TEAS, the IBEW, any of those standardized testings, the ACT, the SAT, you take those GREs, almost forgot about that one. You don't take those exams the same way that you would take an exam in the classroom. In the classroom, your teacher or professor is going to want to see your work. In the classroom, they're going to want to see something so they can give you partial credit. But when you're taking these standardized assessments, you are not going to be given partial credit based off of your scrap paper. They're going to take the scrap paper and they're either going to toss it in recycling or toss it in the trash. That's it. They're not going to look at it. They just care, did you pick A, B, C, D, or some exams E? Did you pick the right letter? That's all they care about. And especially for the ASVAB, how many times have you picked the right letter? Because they do it like they start low and they start getting, it gets harder as you start progressing. And if you keep making the same type of mistakes in one section, that's where they cut you off. Okay, so if you're starting to see more solving equations, you're starting to see more linear equations, graphing lines, talking about slope, talking about y-intercepts, you're doing actually really good. You're in like the late 40s, early 50s. If you start seeing more about volume and surface area, you're in the 60s, close to the 70s. So keep that in mind. All right. Yes, definitely. Poe is the way to go. All right. Edgar Allan Poe. Process of elimination. Okay. And that's how you save a lot of time with taking your exams. Because like sometimes I'll teach you these concepts, but when we do tutoring, I will actually show you samples of, and I'll tell you, if you're doing the ASVAB for Dummies is a great book to use. I like the way their problems are structured. At the same time, it pushes you, so then when you take the test, it's not as stringent. You'll take the test and you'll be like, oh, this is easy. But if you keep getting all these released questions that you get free off the internet and you keep using those are designed to make you feel empowered. Like, oh man, this test is going to be easy. And as soon as you go to take the test, you're going to be like, all the stuff that I was just looking at is not even on this test. Like, what is this? What is that symbol? I have never seen this before. Okay. So I've been doing my research of looking at other people's books and just seeing which ones will work and which ones wasn't. I'm still looking for a really good tease book. And then same with IBEW. It's not a book. There's a couple good online stuff, including my stuff as well. Okay. Yeah. And it's like, we do need to meet again, Jess, so we can get that situated. Because I think I told you the most recent person, he actually passed his. Yes. Star, is that the one from Texas? Because I feel like I've heard it. And I know I helped a couple people. Okay. You need help with that test as well? Definitely. Use it in Hawaii? Okay. I think that's also in Texas as well. And I have been helping a couple students with that. Because I've been using a lot of their released and some other things. So yeah. And then I'm helping one young lady with Regents in New York. So, and she takes her test on Tuesday. And she's going to rock it. Like, she's such an awesome kid. I like her. And she found me here on TikTok, or her dad did, which is so fun. Okay, good. T's, Pretty Eyes, is for people that are trying to get into nursing. So it's like that entry level exam before you guys go hardcore with everything else with nursing. So there's a lot of algebra in there. There's statistics in there, looking at proportions. And if you need someone to do doses calculations, let me see if I can find you again. Yep. So if you need someone to go the doses calculation, you can follow blessed RN. I just put it in the chat. She's really good with this whole thing, doing the conversions, and she has this whole puzzle piece display of how to do the doses calculations without killing yourself with the math. There's just certain things you gotta memorize, but other than once you get that down, you can do the rest of it easily. Yeah, that's what I was thinking about. Pretty Eyes. Star. Yeah, I've helped a couple people with that one. With the double R. Okay. Do you teach and do any of your students follow you? A couple of my students follow me on Facebook. I want to take physics eventually. I need... Okay. So everyone that needs assistance, like, yes, you can watch my lives. My lives does not have a consistency, meaning like 1 minute I can be doing basic stuff. The next minute I can be jumping into data analysis. And you'll see it. Like if you go here, can't say it, but if you go here, you can actually see a lot of the lives and get a good idea. But if you're just like, yeah, I like this, but I really want to have something a little structured or like something that's more geared towards me. Like I've taken the test before and I know I need the areas like here, here, and here that I need assistance with, that reach out to me. Like, it's great to get as much as you can for free. I get it. But at the same time, you don't want to waste a lot of time on certain things. Or if you haven't taken it yet, take it once. I always say, take the test once. And if you bomb it, at least you can get like feedback on what you missed. So now we have a plan of attack. Or you might even take it and just miss it by like maybe 1 or 2 points. I mean, trust me, I've known people that just taken the test by watching the videos and they're just like, I got the score that I wanted to get. All right, awesome. But it's not just a matter of just sitting and watching videos whenever you want. It has to be consistent. And, you want to get things done. Like, I want to say all of you guys really should be taking the test like before Thanksgiving. Like right now, since it's August, give yourself a couple of months. And you should be taking whatever test it is before Thanksgiving. But it has to be a consistent thing. Okay. Think about... Okay. Oh, you're thinking about streaming for them. Okay. Yeah. Anytime. I'm telling you, like, as an educator, you have spent so much time breaking down concepts. Don't, like, just because I do this doesn't mean that you can't do the exact same problems. It doesn't mean that you can't, I didn't invent math. And at the same time, the way that you're going to present it is going to be different the way I present it because we're two different people. Reach out to your audience, speak to your audience, put yourself out there because there are people, there's how many billions of people on this planet? One person cannot service 1% of the world's population. No, you can't. You can try. Go ahead, have fun with that. But no, you can't. Put yourself out there. Do what you got to do. An English book to learn? Yeah, I do not. English is not my forte. Who could you ask? You could ask... Oh, what is her name? Oh my goodness. I just had a major brain fart. Let me see if I can find my friend's name and I can put it in the chat. So if anyone else, if this is too late for you guys, one, thank you so much for coming in here. I'm going to look for, I don't know about English, but let me see if I can find her name. Oh wait, I have to get over here. I know there's so many things that's coming over here. Sharon, do me a favor. When you get a chance, once we get off this live, just send me a quick message. And then there's a friend of mine that just started on TikTok, and she's actually going to be going live soon. Her name is Bridget Hauser. And she does English and math for, like, say, elementary. So, like, if you're just starting off with the English, she knows how to do not only comprehension, but how to break down sounds and all that stuff. I hate to say it that way, all that stuff, but hopefully you understand what I'm saying. So she'll be a great resource to ask a question. And I know she's thinking about going live, and I can't remember when she said she is, but, you know. So if anything, shoot me a message so then I can get you two connected. Okay. Not everyone explains like me. Yeah, because I'm a nut. I tried to put it in easy, manageable ways. Okay, that's my whole thing. I like to break it down till it's completely broken. Till you're like, yeah, I got this. All right. Yep. So I always say go for it. Don't let anybody hold you back. Like, I'm going to actually do a little service plug. So here I have my own math notebook. The reason why I have my own math notebook is because of my students. I got tired of my students coming up with packets of papers, and I'm just like, all right, so what's your notes say? And they had no idea what it was saying. So I said, okay, so this is what I want you to do. I want you to put the information, the practice part here, whatever the formula that you're looking at here, and then I want you to create some steps. So that's what I would do with some of my clients to help organize their thought process. And all of a sudden, it just took off. So not only like 100 of these pages, because, you know, this is our new book now. This is book 6. But in addition to this, I was like, you know, you guys need references. So I have like a reference page. So right here, I have a factor chart. So a factor chart goes from 1 to 200. So if you're not strong with your multiplication tables, if you're not sure what the factors of like 127 is, and maybe because since we're dealing with larger numbers, this book is designed for 7th grade, so like Algebra 1, all the way up to and including adults. So people that are going to get their college algebra credit, or they're taking like basic math or whatever it is. So like I have, this one is designed for pre-algebra to algebra 1. And there's another book that I did for algebra 2 and pre-calculus. So here I have like the squares and the cubes and their roots. I have the certain words that they use for word problems. I have integers and also interval notation. Then here, this is the part that a lot of us need to revisit, those rules for integers when you're adding, subtracting, multiplying, and dividing. Okay, so we have that. Then we have our linear and the quadratic equations. We have order of operations and the properties of exponents. We have decimal operations, adding, subtracting, multiplying, dividing. Okay, what's it look like with examples? Same thing with the fractions operation. Then also what to do when you have to go from percent to a decimal to percent, all that. Place values. Okay, someone asked me about distance, speed, and time. Here it is. Okay, so if you're looking for your distance, cover the distance. You always cover what you're looking for. So if you're looking for distance, cover that up. That's speed times time. Then if you're looking for speed, that's your distance over time. If you're looking for time, that's your distance over speed. You're dividing. So you're using all of these. Your measures of central tendencies, your triple M's, mean, median, and mode, not range. Range is not a measure of central tendency. That is the measure of variation. Okay? Also, arithmetic and geometric sequences. Okay? All of this. Okay? Right. So that's your system of equations, your system of inequalities, all of that, all of these references. Now, I could put everything from Algebra 1 all the way to pre-calculus as a reference in one book. But then the book will be thicker than a Snicker, right? It's already thick as hell now. And that's why it's expensive. And I print in color. A lot of books that you get, any of these, are not printing in color because we all know color is expensive. Oh, and that digs into how much money I put in my pocket. Look, you guys pay for the book. You pay for the shipment. If I get a little bit of extra from it, all right, great. But at least you got a book that's giving you the resource. School is starting up, okay? If you don't want to have your own notebooks, then you can get a copy of my notes, which is Audrey's notes. Okay, all the notes that I have here on TikTok. We just finished book number 5. That's going to be out this weekend. Okay, so all you have to do is, there's a QR code. You scan the QR code, and it takes you directly to the live that's associated with these notes. So then you will basically follow along step by step. It's great for remediation. It's great for enrichment, for homeschool parents, for teachers, for students of all ages and abilities. Get it. And it's in color. Because I feel that using different colors, just in case you haven't figured it out by now, by using different colors, this is going to be, it's easier for you to follow along. Whereas if it's all one color, you don't know where to go. Like, what should I do? What's important? What's that phrase? What's that saying? So, but if you are interested in any of those, and even my left-handed book, notice we're going to open from the other side, and it still has the same resources just like the other book. It just opens the other way. All my lefties out there, including my papa, okay? His anniversary of his death is coming up, and I dedicated that book to my dad. Yeah, it's going to be next week. I'm going to try to be here. That's next Wednesday, actually. So, I don't know. I'm going to try. But, yeah, so, dedicated. That's what he looks like. You handsome gentleman. Okay. Oh my God, 100K? Jeez, I've been talking that much. I am so sorry. But again, if you want any of the books, you can either go here. Okay, you can take a nice little screenshot. So that'll be like the math notebooks, the Audrey's notes, and I'm working on a workbook. I'm shooting for around Thanksgiving for the workbooks to be out and about. But you also can come here if you want to have anything about tutoring. I'm not sure if you can see everything. Okay, so if you have anything about tutoring, I do private and I do small groups. As I said, there is a special price for my TikTokers than for everyone else. But, and it's just for you. Don't just try to bring all your whole family in there, because guess what? I got to pay my mortgage just like everybody else does, okay? I got to eat too. All right. If you want to do a self-paced course, GED, ASVAB, ACCUPLACER, TEAS, any of those, you can just buy the course itself, or you can get the course with 2 30-minute tutoring sessions. Sometimes the tutoring sessions might be a little bit longer, depending on what's available. All right. So if you want to take a screenshot of that, you can. And let me take a look. Oh, yes. Yeah, I can't say the big A anymore, but it is on all of my books. Everything is, I'm either doing my own private bookstore or the A. But I can't say the A because then I get dinged from TikTok. And everyone knows what the A is. I hope. You know, with the big brown box with the smile on it that everyone is always getting deliveries from. Yeah, that. So it's there as well. If you order from there, yeah, I get 50 cents per book, but at least you'll get your book a lot quicker. Whereas if you order here, you get it in about a week. It's usually not longer than a week. Unless it's like the holidays, like Christmas. That was forever and a day. And everything started running together. Run together. We'll call that. Don't run that. All right. Well, thank you. Yes, I'm definitely worth every penny. Yeah, every penny. So when you open it, just get confused. You open it, just get confused. Oh, when you read it. So is that the Audrey's notes? Sharon? Which one was it? Every dollar. Every single cent. Yeah, because it's almost like really just trying to keep track of your notes. That's the one thing. Like a lot of students don't take notes anymore. So that's one huge thing. Okay. All right, everyone. Oh my goodness. 99.6. My goodness. You guys have been tapping. But again, my goodness. You guys have been tapping. But again,